Good morning, everyone. Dear students, I am Sandeep, physics lecturer at Acumen Junior College, and my JE 2005 All India rank in general category is 568. I'm proud of it. Today, see, many of my students have went wrong in solving the questions in the exam. Now, so what I have thought is, see, most of my students can do all the questions of JE mains, but then they went wrong in many of the questions. So what I thought is, it would be a nice idea if I can uh, make a video on the possible errors in each of the questions. So I am going to analyze each and every question very keenly. So if you can follow, this will be very useful for you. So let us see the first question. This is January shift, January's exam, January 2026. And the first day morning exam, morning shift exam. So mostly it is 22nd January, I think. Yeah, so let us see. Look at this. See, here in this question, potential energy versus distance graph is given. So first of all, potential energy is defined for a system. Okay, for a system. Now, of course, he didn't say that it is not defined for a system, but yeah, he's asking you the force on a particle. Now, when he's asking you force on a particle, there is no way you can picture out what kind of potential energy it is and what is happening in the problem actually. So this is just a problem based, like formula based question. That is, you should be knowing that F conservative is given by minus dou U by dou X. And of course, he's asking about magnitudes. Don't miss out that. So you're supposed to take the magnitude of this. So you are comparing the force magnitudes. Now, generally, force conservative force is given by minus dou U by dou X, I cap, minus dou U by dou Y, J cap, and so on. So, force is a vector, as you know it, isn't it? So, if it were not magnitudes, then you cannot compare the vectors like this. You cannot draw the order for the vectors like this. So, that will be difficult. Anyways, he has given only a single variable here, that is in x direction, u versus x or v versus x. So, we are not having any problem on this. Now, the point is, here he says high to low again. Okay, already he is saying that you are supposed to rank them high to low. That is the largest one first, the least one last. So you don't require this symbol again in between, isn't it? That is one thing you can see. And then here, when we are talking about F conservative is being minus dou U by dou X, the magnitude of this is nothing but the slope of U versus X graph. So you are going to compare the slopes, irrespective of slope is positive or not. We don't care. We are going to compare the magnitudes of the slopes. So finding the slopes is easy, but you don't have to find the slope literally. The steeper the line, the slope will be higher, isn't it? So obviously the BC one is the most steepest line. And then which one do you think is steeper, or DE or OB, AB? You can find out this is 45 degrees angle. You know that. And DE, you see this is 2 units and this is 1 unit. Okay, 4 to 5. So this angle will be lesser than 45. So therefore, the lesser than 45 means it is more inclined towards horizontal. So the steepest is BC, then comes AB, then comes DE, And then obviously comes CD. CD has slope 0, that you know. Okay. Now, we'll go to the next question. Yeah. See, this is very elementary question. Even a 8th class kid should be able to do. Elementary means you should understand the question, then it will be very easy one. See, here we are supposed to equate the rate of heat given to the water must be equated to the rate of heat coming from the gas combustion. Okay. So he is giving you the calorific value, you can say, or you can say the heat of combustion of gas per gram he is giving you. So take care, because 5 liters, maybe the students usually the students know that 5 liters is equivalent to 5 kgs of water. But yeah, if somebody doesn't know, okay, for them it is 5 liters. And then here the temperature is given in Celsius. It doesn't matter, because here we require the change in temperature, that is delta T is anyways 60 degrees, so no issues. So dq by dt, that is heat consumed by the water. We'll see first. 5000 grams of water per second multiplied by the specific heat capacity of water, that is 4.2 joules per gram, multiplied by change in temperature, that is 60 degrees Celsius. Okay. Now the same dq by dt has come from consumption of gas, because the gas is burning. So how much gas is burning? We don't know. Let it be x grams per second multiplied by each gram of gas will liberate what? 5 into 10 power 4 joules. So therefore, when you equate them, you should be getting your answer. Yeah, of course, you are supposed to do your calculations properly. The next one is a conducting circular loop of area 1 meter square is placed like this. Now he says that loop is perpendicular to magnetic field. It means that the magnetic field is like this, B, and the loop is like this. So basically the area is parallel. When the loop is perpendicular, the area is parallel to B bar. So that's what it means. So therefore, you can find the flux phi is equal to B bar dot A bar, that you know. And then you just have to multiply, because anyways the angle between them is 0. So it becomes cos 0. That's one. And then what else you will do? You will find the current. How will you find the current? By doing d phi by dt, because phi you will get as sine 100t. By doing d phi by dt, you will get 100 cos 100t. And then this is the EMF. We just need the magnitude of EMF again. You don't require the sign and all. And then you will find current, Okay. How much is the current? 100 cos 100t divided by 100. So that will be cos 100. Now, why do I need current? Thermal power. Power. I am talking about power, not energy yet. So power is given by I square R. So that will be cos square 100t multiplied by R is 100 again. Now, this is average power. Okay. Average power, you can say. Not average power, this is instantaneous power. So you can find average power by doing the integration process. By doing the integration process. So how do you do that? Integral P instantaneous dt divided by integral dt will give you the power average. Now what do you do with power average? You can multiply the power average with the time period, then you will get the thermal heat energy which is liberated. Now, but an important thing here, average thermal energy is given. There is nothing like average thermal energy. We are not talking about thermal energy released in different time periods and taking the average here. One time period, we are supposed to find the heat energy liberated. So here the average, the meaning of average, I don't think it is there. It's useless to give average here. Just thermal energy should be sufficient. So the thermal energy liberated, how do you calculate? By doing this calculation, we calculate. And of course, a small thing, a quicker way to do this question. I mean, some people may integrate and do it. I don't say it's wrong. Integral P instantaneous dt should give you the heat energy. This should be a direct thing. But this will be little late. Rather, you will find P average and then multiply by time period. It will be easier. Why it will be easier? Because I'll show you the process why it will be easier. You see, integration I square r 100 into cos square 100t dt. This is what it is. That's it. This is the answer. This is how you'll get the answer. But what I'll do is I'll divide and multiply with 2 pi by 100. What does it give you? Is this one. Observe this carefully. This one, the average, that is average of cos square theta, that is half. So when you have that, you will get the answer directly as pi. That is half. Half multiplied by 100 into 2 pi by 100 should give you pi as the answer.